Hello, my name is Dan Klebishaw. I'm the president of FOSS North America. It's a pleasure for my team and I to introduce you to a series of short webinars focused on NIR feed analysis. This educational series is intended to introduce you to the basics of NIR technology, the latest FOSS innovations in the field, and to discuss how our near-infrared solutions are helping feed mill operations like yours utilize NIR to improve feed consistency and operate more profitably. The animal feed industry produces over 1 billion metric tons of feed annually, which is an essential part of feeding the world's population. There are many challenges in feed manufacturing. One of the core challenges that feed producers face is one of variation. And a key variation of interest is the price or cost of feed ingredients. We know that ingredient prices vary over time across geographies and may be greatly influenced by many factors, including growing conditions, global supply, and even geopolitical policies. These charts demonstrate the wide price variability for a couple of important feed ingredients, namely soybean meal and fish meal. You'll see that soybean meal prices over the past 10 years peaked at $640 a metric ton, with a 10-year low of $300. In 2018, soybean meal reached a high of $470 a ton, and a low of $375, which was a 20% price fluctuation for just a portion of 2018. Fish meal in 2018 had a high of $1,850 a ton, a low of $1,400 a ton, which was just under a 25% variation. So some ingredient prices have remained fairly constant in recent years, and others, like these examples, have fluctuated significantly. But another critical variation is the nutritional variation in feed ingredients. Of course, feed ingredients are natural products, so we expect some variation, but there may be more variation in your ingredient supply than you might realize. These graphs, supplied by Dairyland Laboratories, are based on actual real-world samples. The data shows appreciable, perhaps even surprising ranges of variation, which, if not well managed, could have a negative impact on the consistency of your feed product. The concepts of Peter Drucker and Edward Deming, thought leaders in the area of quality management and manufacturing processes, are highly applicable in modern feed manufacturing today. Uncontrolled variation may be the enemy of quality, as Deming suggested, but what practical tools are available to a feed producer to understand and manage this variation? And using measurements to manage variation, as Drucker suggests, makes sense, but the feed industry doesn't just need more measurements. It needs faster, more timely, and accurate measurements in order to make more real-time decisions, and a system to better use this measurement data to make broader systematic improvements to your operations. Understanding and controlling feed ingredient variation is an obvious desire for any feed operation, but how is this best done? What innovations have been developed to make rapid on-site analysis practical, particularly for mid and small-sized mills that may not have extensive experience or resources to support a complex analysis system? And to bring the discussion to a point, can today's NIR feed analysis be a breakthrough capability for you to practically improve your feed manufacturing process? I hope this webinar will answer some of these questions, and that my staff and I will have the opportunity to work with you to explore the use of our solutions within your feed business. To fully appreciate the power of NIR for feed analysis, it may be helpful to discuss and then compare NIR to the contemporary methods otherwise used to analyze proximates in feed and feed ingredients. Traditionally, feed analysis was performed with what could be called wet chemical analysis methods. And without going into a lot of details, these methods use solvents, involve extraction or digestion, combined with titration, to produce analysis results. This slide shows the range of FOSS chemical analysis solutions which we've offered for decades, and still do, for the analysis of protein, fiber, and fat. One key point in understanding the limitations of chemical analysis methods is that each test is specific for an individual proximate parameter, and each test takes a considerable amount of time, typically in the range of hours, and again, just for one proximate value. And of course, since you're dealing with solvents, you have to deal with solvent safety and solvent waste that is produced during the analysis. While there are drawbacks and limitations to these traditional methods, it must be understood that they're still extremely important. These kinds of solutions are widely used and accepted, produce accurate results, and are commonly used in feed companies' central laboratories or in third-party commercial testing labs. While these tools are invaluable for the industry, they do not offer the rapid on-site analysis that feed manufacturers need today because they're simply too slow. This slide highlights the differences in different analysis approaches with respect to the important time to result parameter. In other words, how long does it take to get an analysis result that you can then take action on? Here we compare an on-site NIR approach, which typically has an analysis time of less than a minute, to an in-house chemical analysis method that can take hours, and the practice of sending samples to a third-party lab for testing, which can take days. This simply illustrates that only NIR is uniquely able to produce results fast enough for real-time decisions. And this is important if you want to have analysis results before you receive a load of ingredients, for example, or before you ship a lot of finished feeds. Getting results in hours or days just isn't useful for these purposes. So now let's discuss the basics of NIR technology. And to start with, let's talk about terminology. NIR is short for near-infrared spectroscopy. Near-infrared spectroscopy uses light in the near-infrared region, which is between the visible and the infrared ranges, and in terms of wavelength between 800 and 2500 nanometers. This near-infrared light interacts with sample material, such as feed ingredients, in a specific way depending on the sample composition that allows us to predict qualitative and quantitative properties in samples. Practically, what this means in the case of our DS2500 near-infrared system, we typically analyze solids using a sample cup as shown in this picture. And this cup can receive either ground or unground materials. Near-infrared light travels from the spectrometer through a transparent quartz window in the bottom of the cup and interacts with the sample. The cup rotates during the measurement to obtain a better average result. The near-infrared light that interacts with the sample has specific wavelengths that are absorbed by the sample according to certain chemical bonds being present in the sample. For example, carbon-hydrogen bonds associated with fats, nitrogen-hydrogen bonds associated with protein, or oxygen-hydrogen bonds found in water, all absorb in specific wavelength locations. And the intensity of the absorbance corresponds to the concentration within the sample. The near-infrared spectrum is simply a chart with the wavelengths on the x-axis and the absorbance intensity on the y-axis. Here are some examples of near-infrared spectra of feed meals and milk powder. If you look closely, you'll see that some absorption patterns are more prevalent than others. The near-infrared spectrum in and of itself is interesting but not useful for our purposes. To get useful information, we need to apply a near-infrared calibration model. The calibration model uses advanced math, a specialized field called chemometrics, which essentially converts the near-infrared spectrum into a predicted result for unknown samples. One of the valuable aspects of near-infrared is that you can get multiple parameters in a single NIR scan. So in this example, we have 5 parameters: protein, fat, moisture, ash, and fiber, and we're expressing a value in terms of percent concentration for each of those values. And this is all generated from a single scan that can be accomplished in less than a minute. The good news is, if you don't understand the details of spectroscopy or chemometrics, you don't have to be an expert to use a modern NIR. We'll take care of these technical issues so that you can just focus on using the values to better your business. The key to success for NIR feed analysis is the NIR calibration. A calibration is developed by acquiring a wide range of samples of each type used. For example, multiple samples of finished feed and feed ingredients. We collect the near-infrared spectrum of each of these samples and pair the spectrum with an accurate reference value, generally obtained from chemical analysis methods, which we talked about earlier. The data is then processed using special software to produce a mathematical NIR model, which once developed and validated can then be used to predict the desired properties from unknown samples. And this is a key point because developing robust NIR calibration models can be very time intensive and sometimes, particularly if you're inexperienced to the process, a little frustrating. Why? Because the calibration challenge is high for feed analysis since we're working with a vast range of different ingredients and different combinations of feed formulations. To overcome this challenge, FOSS has innovated again and has developed comprehensive global finished feed and feed ingredient calibrations that are ready for use and supported by our expert staff. The FOSS feed calibrations have been developed over 15 years, includes over 50,000 samples from around the world through multiple growing cycles, and the calibrations contain over 300,000 reference chemistries. We've invested millions to create ready-to-use feed calibrations so you don't have to. Another important FOSS innovation is our ANN calibration technology. ANN stands for Artificial Neural Networks, which involved special machine learning algorithms pioneered by FOSS to make operating and maintaining NIR calibrations easier and more accurate. Now I'd like to introduce you to the FOSS DS2500 NIR system. The DS2500 is widely considered the NIR gold standard by many companies in the food and feed industry. This is our 4th generation platform offering the latest in analytical performance and reliability. The DS2500 offers the widest available spectral range. It's available in 2 configurations. The DS2500 operates from 400 to 2500 nanometers, which includes the visible. The DS2500F, which stands for feed, operates from 850 to 2500 nanometers, which covers the full near-infrared range. The DS2500 was engineered with an IP65 rating to ensure its suitability for use in feed mill operations and making sure it can handle humidity, vibration, and dusty environments that are often found in feed mills. Operating the DS2500 is very simple. The basic operation involves loading the sample cup, again, either with ground or unground material, pressing the start button, waiting a few seconds for the scan, and then seeing your accurate results. The process can be easily learned by operators in just a couple of minutes. And with the DS2500, you can be assured that you're going to get accurate results every time. This slide shows the user interface, which has a nice, clean, simple, easy to follow layout. Results are prominently displayed. You can also capture user-defined fields, including information regarding your supplier, your load numbers, your orders, and any other parameter that you would find useful to connect to the NIR results for later purposes. You can also look at historic trends and set production limits, which will be shown in a later webinar. The reasons to consider NIR for your mill is 1, it's extremely rapid. We've already talked about the quick test time of less than a minute. It's easy to operate. It can analyze all proximate values in a single test, as well as several advanced parameters, which we'll talk about later. Also, near-infrared has a quite low cost of ownership, as there's no consumables costs associated with the test. This means you can test as often as you want for no additional cost. And most importantly, NIR provides the information you need when you need it. In addition to our own proprietary NIR feed calibrations, FOSS also partners with a number of other companies who provide advanced NIR analysis based on our DS2500. And this can include specialty ingredients and other feed manufacturing know-how and value-added services which may be useful to your business. FOSS and our partners work together to provide you the best possible NIR analysis solution for your business and your specific needs. If you're interested in more than just proximate analysis, we can work with our partners to extend your analysis capabilities. Today, 19 of the 20 largest feed mill companies depend on FOSS NIR solutions to optimize animal nutrition and their plant efficiency. FOSS has developed several new solutions to make NIR easier and more valuable to feed mills of all sizes. I invite you to enjoy the rest of the FOSS NIR Feed webinar series, which focus on specific areas where your feed operations can gain benefit from NIR to make better feed and operate more profitably. If you think it's time to take a closer look into NIR feed analysis, I invite you to contact us. My staff understands NIR technology and the drivers for your business. We'll be happy to provide you any information you need and to discuss the specifics for your business.